All right, as we get prepared for what's ahead, this little video is where we've been and where we're going. A trip down memory lane. Okay, that's our moment right there. Okay, we're going down memory lane. Hopefully you're going to remember all of these things. You'll see a worksheet that goes along with this. As we go through things, make sure you're filling out questions, pausing, all that sort of stuff, writing down other examples. You may not use the ones that I've come up with here. Please try and refrain from using ones in the book. Thank you very much. All right, first things first. Rate. What is a rate? A rate is a description or comparison of two different quantities. Okay? We've seen many of them, many different types. Often we see the word per involved in a rate, but not always. Check out the examples. Oops, that's supposed to be an S. This is supposed to be a 2. That's what happens when you backspace. Okay. All right, so those are some of the examples. You need to write in a few of your own. Pause it if you need to go through that process. I'm gonna move on. Next one, the bumblebee slide. Linear relationship. What does it mean to be a linear relationship? Well, two variables are said to be a linear relationship when the points on the graph of those two variables lie on a straight line. Linear. Some of you like to call these linear relationships. Well, it's technically pronounced linear, but we're not going to cry over that. Line are linear, so it has to be a straight line. As one variable changes by 1 unit, the other variable, apparently I can't type today, changes by a set amount. The set amount is called the rate. Hey, wait a second, we just saw that word on the last slide. Oh, they must go together. Examples, m is equal to 5t. That one should be familiar. The number of milliliters, 5 milliliters in each teaspoon. So the 5 shows that the m changes 5 units when t changes 1 unit. So as we add another t, we add 5 more m. Another t, 5 more m. We would get a straight line. And we're going to work with that today or tomorrow. Sorry, not today. Tomorrow. Next one. Pause it if you need to. Proportional versus non-proportional. I'm sorry I picked these colors. They kind of make me sick. But okay. A relationship between two variables where if one gets bigger, the other gets bigger at a constant value. That's what it means to be proportional. Now, for instance, this one makes it a little bit more clear. The number of dollars earned is proportional to the number of hours worked, because if I double my hours, if I work twice as many hours, I also double the amount of money that I get. Yay for working double hours. Okay, so double and double. If I triple it, I triple it. Okay. If I add another hour, the other value goes up by something. If I add 2 hours, it goes up by the same value that it did when it went up by 1 hour. Okay, or a value that is proportional. For a non-proportional relationship, this top part does not hold true. For instance, if I make $45 just because I'm a teacher at ICS, but then I get $25 per hour, that's not proportional because of this 45. No matter what I do, even if I don't work on Sunday, I still get 45 bucks. Yeah, that would be great, but that's not how it works. Okay. So this is non-proportional. We've seen that a proportional equation looks like this. Y is equal to 2x. Okay. And we've seen that a non-proportional equation looks like this. Okay. So that makes the difference. Next slide. Blue and green. Speed. Speed has been one of the most recent topics. You worked on it either in class or at home by walking across the room or out in the courtyard or whatever. Speed is the most commonly used rate. We can use speed as all of the following: kilometers per hour, miles per hour, feet per second, meters per second. Depends on how you measure things, whatever. If you're in a car, you're going to do this. If you're on foot, you're going to do that. Okay. So this would be car, plane, train. This would be on foot. You might do it in bikes. Depends on how fast you ride on your bike. Kilometers per hour or miles per hour. Yeah. Okay. Last one. Graphing. Okay. This is something we're going to start doing more of, and we're going to need to recognize something that we're going to see tomorrow in class. Okay. If I'm told I'm going to make 700 baht each hour, oh, what is wrong with me? Don't answer that. I can see what that would look like in a graph. First, I would make a table. Okay, so I go through the process of making a table with hours and pay. I do 1 and 700, 2 and 1400, 3 and 2100, 4 and 2800. I don't know what I'm doing. Sorry. Okay, 5 and 3500. That gives me my values. So then I create my graph. Okay, here's my table. All right. I mean my chart, my graph. Okay, here are the number of hours, the number of pay. Notice I've already given it a title, baht per hour. That's what some of you are forgetting to do. And then I draw a whole bunch of points. Okay, 1 and 700, 2 and 1400, 3 and 2100, 4 and 2800, 5 and 3500. Okay. Sorry about that. Alan just interrupted me. I don't remember what I was saying, but yeah. Okay. Now, first off, why did I connect the dots? Wait, what? Yeah, that's because you can have half an hour. Okay. Remember, we connected if we can have all of the values that are in between these two. This being 1, this being 2, 3, 4, and 5. Okay, so it's okay to have 4 and 2/3, so we can move up here. Is it linear? Yep, linear. Is it proportional? Yep, it's proportional. Okay, if I double my hours, I double my amount of money that I get. Okay, so that is the concept. Those are the concepts that we need. What we're going to do tomorrow is we're going to begin to recognize the similarities between rate or speed and slope. Okay, so yeah, good to go. If you have any questions, ask them. See ya.